Hi everyone, welcome to my tutorial video. In this video, we're going to walk you through how we can develop a simple game simulation step by step using the design pattern. So we'll start with the sprint 1 and then improve it in sprint 2 and then finally add more features in the sprint 3. So what are we waiting for? Let's get started. Okay, now let's begin with the sprint 1. So in this sprint, our goal is to create a different type of game characters, a warrior, mage, and also a marksman. So to make this flexible, we'll use a factory method design pattern. So this will allow us to create characters dynamically without directly initiating them with new everywhere. Here, I'm creating an abstract class called Game Character. It has one abstract method called Attack. So this means every specific characters like a warrior or mage will provide its own version of attack method. Now, I create 3 concrete classes, warrior, mage, and marksman. Each one overrides the attack method to display different behavior. The warrior charges, the mage casts a magic, and the marksman shoots an arrow. This gives each character its own unique action. Here's the factory method part. Instead of manually doing a new warrior or a new mage, I build a character factory class. It has a create character method that takes in a string. If I pass mage, it will return a mage object, and if I pass a warrior, it returns a warrior, and so on. This way, I can create a character dynamically just by changing the input string. Now that we've built our characters and the factory, let's bring everything together inside the main method, which is the starting point of our program. So in this part, we first create a scanner object so that the players can type their choice. Then, we ask the players to choose a character, which can either be the warrior, the mage, or the marksman. So whatever the players types in is passed to our character factory, and the factory takes care of creating the right object for us. For example, if the player types mage, the factory will return a mage object without us having to manually write a new mage. After that, we simulate a little gameplay by calling the attack method on the chosen character. So depending on the choice, the warrior will charge into battle, the mage will cast a spell, or the marksman will fire a deadly shot. And finally, we close the scanner to keep our program clean. So, the main method is really the part where the player interacts with the game, while the factory works in the background to handle the character creation for us. Now, let's proceed to sprint 2. So in this part, we want to improve our game by adding weapons and power-ups. But instead of hard-coding them, we'll use the abstract factory pattern. So this lets us group related objects like a medieval sword and a health potion, or for the futuristic laser gun and energy boost. That way, when we use a theme, we get a consistent set of assets. In here, I'm upgrading the game character from sprint 1. Now, each character can have a weapon and a power-up. I also added methods like use weapon and use power-up, so each character can use the item assigned to them. Here, I created medieval themed weapons like sword, bow, and staff, and power-ups like health boost and mana boost. Each one just prints out its effects when used. Now, I add a futuristic options, a laser gun, and an energy boost. Later, the player will be able to choose between medieval and futuristic themes. Now comes the abstract factory patterns. The game asset factory interface defines two methods: create weapons and create power-ups. Then, I create two concrete factories, a medieval factory and a futuristic factory. The medieval one always gives a sword and health boost, while the futuristic one always gives the laser gun and the energy boost. This ensures a consistent set of items. Finally, in the client, I ask the users to choose a character and a theme. Based on the theme, I select the right factory. Then, I assign the weapons and the power-ups to the character. When I run the simulation, the character can now both attack and use their weapons and activate the power-ups. So this one completes our sprint 2. Now, let's proceed to Sprint 3. In this sprint, we enhance our game system by introducing two powerful design patterns, Singleton and the Builder. This pattern makes our code more organized, more flexible, and easier to maintain, which is exactly what we need as our game grows in the complexity. Let's start with the Singleton. The Singleton ensures that there is only one global game setting or game manager object in the system. This is very useful for managing settings that needs to be consistent across the entire game, such as the difficulty level. The key thing to note here is that the constructor of the Singleton is private. This means that no one can create a new instance using new. Instead, we use the method called getInstance. So this method checks if the instance already exists. If it does, it returns the instance. If not, it creates it. This guarantees that there is always exactly one instance. Now, let's talk about the builder. The builder patterns allows us to construct a complex object step by step. Instead of creating a character with a huge constructor that takes every possible attributes at once, we can start with the character type, then chain method calls to add the weapon, attach a power-up, or set other optional features. Once everything is configured the way we want, we call build to create the final character. This approach keeps the code clean, readable, and very flexible. It is especially useful when we want to create a character with the different combinations of weapons and the power-ups without having to rewrite the constructor every time. In the client demonstration, we first showed the Singleton in action by setting the game difficulty. This immediately applies to all the characters in the game. Then, we demonstrate the builder by creating a custom character step by step. The user selects a character type and a theme, attaches a weapon, and adds a power-up using clear, readable, and chain method calls. Once the characters are built, we simulate a gameplay. Each character attacks and uses their abilities, showing how the pattern works seamlessly in the structured environment. In summary, Sprint 3 highlights how the Singleton in the builder patterns complement the design we introduced in the earlier sprints. The Singleton guaranteed a shared, consistent game settings across all components, while the builder simplify the creations of complex objects and improve code readability. Together, these patterns helps us to create a robust, scalable, and well-organized game system that is easy to extend as new features are added. And that's a wrap. In the first sprint, we learned about the factory method to create characters. In sprint 2, we expanded with the abstract factory to add themed weapons and power-ups. And lastly, in sprint 3, we added singleton to singleton for a shared settings and builder for flexible character creation. This step-by-step approach shows how we can evolve a system using design pattern, making the code modular, extensible, and easy to maintain. So this will be the end of my video tutorial. I hope everyone learned something in this video, and thank you everyone for watching. Bye!